Hey everyone, in this video we are looking at why just-in-time access is important for cloud security, and I'll show you a quick demo of how you can set up a simple JIT system in GCP using IAM roles, conditions, and a Python script. If you're working in security or cloud engineering, this is a must-know. Let's dive in. Let's start by understanding why just-in-time access or JIT is so important for security. Just-in-time access means giving users permissions only when they need it and for only as long as they need it. In traditional environments, we often grant long-term permissions or leave credentials lying around, and that's risky. Secrets can get accidentally committed to source code management systems like Git or shared in places where they shouldn't be. JIT helps fix this problem by removing permanent access and giving teams access just in time for what they need to do. Now, if you're in security, you have definitely heard of zero trust. It's one of the foundational principles of modern cloud security. The core idea of zero trust is simple: never trust and always verify. And JIT Access directly supports zero trust in three important ways. First, it enforces least privilege. That means users only get the access they need when they need it, and that access is automatically revoked when the time is up. Second, it supports context-aware time-bound access. You can tie access to time windows, justifications, or even approvals, depending on the risk level. And finally, it removes implicit trust inside your environment. Just because someone has a login doesn't mean they should have access to production. JIT makes access explicit, temporary, and verified, and that ultimately reduces your insider risk and the risk of lateral movement. So whether you're a developer or a security leader, JIT is a simple and powerful way to keep your accounts safer and more aligned with modern cloud security standards. Okay, so now let's see how we can set up our JIT system in GCP. To build a just-in-time access system in GCP, the first thing we need is RBAC, or role-based access control. RBAC means assigning permissions to users based on their roles and not directly assigning them to individuals. This is important for JIT because users will request temporary roles, and RBAC lets us control exactly what they can do and where. In GCP, you implement RBAC using IAM roles, and there are three kinds of IAM roles in GCP. You have custom roles, which is the most secure option because they let you handpick only the permissions you need, and you can set those permissions based on your own organizational security policies of least privilege. Then you have predefined roles, which are managed by Google, and they are curated for specific services and personas. And finally, you have basic roles, which is like owner or editor or viewer. And this is the least secure option because these roles grant too many permissions across all Google Cloud services, and therefore they are in breach of least privilege and they must never be used in production accounts. For this demo, I have created three custom roles, three custom GCP IAM roles: JIT admin, JIT developer, and JIT reader. And we will use these roles as part of our JIT access flow. And if you see in the GCP IAM section, you will notice that we do not have any bindings for these users, or sorry, bindings for these roles, meaning these roles are not attached to any users or identities in this GCP project. These are just pre-created group of permissions at this point, and in the next section, we will see how our JIT system would create bindings for these roles based on just-in-time requests from user personas. So this is how a JIT access system works at a high level. Let's say a developer or engineer needs temporary access to a GCP project. They interact with the JIT system and submit a request of input parameters, the GCP project, the role for which they need access, the duration of access, and a short justification. Now, this JIT system could only be accessible by authorized company employees, either by using SSO or some other internal security control. The system itself could be in the form of a user interface or a web form or a Slack workflow, or even an email-based process, right? Whatever fits your organization. Before granting access, the JIT system could also have an approval workflow using either the user's manager, or it could also be using a designated admin or a team lead. Once this request is approved, the system creates a temporary IAM binding, right? IAM binding in GCP basically means attaching a user or an identity to a GCP IAM role, right? But this binding would only be created for the approved duration, which is provided by the engineer themselves. After that time expires, this access is automatically revoked, helping enforce least privilege. Of course, for the JIT system to create these bindings, it also needs to have elevated access, often at a GCP org level or the folder level, so that it can create these bindings for all the GCP projects within this org or folder. Once the bindings are created, the user can now log in into the GCP console and see the project and permissions they were granted by that particular role, all in a very secure and time-limited way. Now let me show you a demo of how this JIT system can be created using Python code. All right, now let's take a look at the actual demo of how this JIT system works in GCP. First, I'm logged in to my command line using a JIT system user. This is the CSM demo user 121 at gmail.com. And this is the identity that has the necessary permissions to create IAM role bindings. And you can also see from the GCP console that this CSM demo user 121 has project IAM admin role added to it so that it can create IAM bindings in this GCP project. Next, I will open the Python script that powers our JIT system. This is a simple proof of concept, but it shows how the JIT logic can be implemented. Let's quickly go through some of the key parts of the script. First of all, it uses kkinter to provide a graphical user interface. Um, it then collects the key input parameters from the user. This is the GCP project ID, the user email, the role, the duration of access, and the justification. And under the hood, it actually uses gcloud to be able to create those IAM policy bindings. And so it's taking the user parameters and passing it to the gcloud command. But you can also see that it's automatically restricting access using GCP IAM conditions to expire the access after the requested duration. So it's doing that using this condition clause, where it's checking if the request time is less than the end time, and that end time is actually calculated using the duration that the user has requested access for. Now let's run the script from the terminal, again using our JIT um, system user credentials. And this opens up our JIT access interface, or our mock JIT access interface. And this is a basic GUI window built using Python. And it's a mock system, but it's in a real world setup. This could be a web page or a Slack integration, and it's basically asking for input parameters from the user, which is GCP project ID, the email of the user, the 3 roles that the user can select, and the duration, which could be selected from 8 hours, 7 days, 31 days, and some textual justification for access. Okay, now that we have set up our mock JIT system, let's switch gears and look at this from an end user's perspective, a developer who currently does not have access to the GCP project. So I've logged in to this mock user called CSM demo user 999 at gmail.com. And as you can see, this user currently does not have access to any projects, and it has no visibility into the target project as well, which we have been working on. So this user does not have any permissions assigned yet. Now this user opens up this mock GCP JIT access form which we have created, and this is the mock interface for requesting access to the GCP project. So they put in the GCP project ID for which they want access, the user email, and select one of these three roles. We'll select the developer role and the access duration of 8 hours. And then we provide a quick justification. Now we'll click on request access. So this is the temporary access granted for developer for 8 hours. We'll click on OK. All right, now let's go back to the GCP console as our mock user and hit refresh. And let's go to section again, and there it is. The user can now see the GCP project that they requested to. This confirms that the JIT access flow worked as expected. I will go over now to the IAM section, and here we can see that the role binding has been created for the JIT underscore developer role and is attached to the user which requested it. And what's important is that this access is not permanent. And how do you know that? Because there is a condition attached to it. If I click on this condition, it says that the access is only valid before this timestamp, right? And if you remember, we requested access for 8 hours, and I created this video on this date, and this is definitely less than this is definitely 8 hours from where I created this, from where I requested this access. Okay, so that's it for the demo, folks. We saw a quick and simple way to see how just-in-time access could be used for granting temporary automated cloud access in GCP. Hope you find this video helpful. If you're building secure access workflows in the cloud, definitely consider using JIT as part of your security toolkit. Thank you.